The truth about camel humps everyone gets wrong. Everyone knows what's hiding inside a camel's hump, or at least they think they do. Ask almost anyone and you'll hear the same answer: water. It seems to make perfect sense. Camels cross scorching deserts for days without drinking, so surely that giant hump must be a built-in water tank. Except it isn't. If you could look inside a camel's hump, you wouldn't find water sloshing around at all. You'd find something far surprising: a huge store of fat. That raises an even bigger mystery. Why would carrying around a giant lump of fat help an animal survive in one of the hottest places on Earth? Wouldn't extra fat just make the camel even hotter? The real answer turns out to be much cleverer than the old myth. And once you understand it, you'll never look at a camel the same way again. The idea that camels store water in their humps has been around for generations. It's easy to see why. Travelers watched these animals march across deserts where water was almost impossible to find. While horses or people quickly became exhausted, camels kept moving as if the heat barely bothered them. The hump seemed the obvious explanation. For centuries, many people imagined it worked like a giant canteen. The larger the hump, the more water the camel carried. It sounded perfectly logical. But when scientists examined camel humps, that idea disappeared almost instantly. Inside, there was no hidden reservoir, no giant water-filled sack. The hump was made almost entirely of adipose tissue, the same kind of fat found in every mammal, including humans. So if the hump isn't carrying water, what is all that fat doing there? The first clue appears when food becomes scarce. Imagine you're about to hike across a desert where there may be nothing to eat for days. Carrying extra food would be useful. A camel solves that problem by carrying its energy on its own back. Fat is one of nature's most concentrated forms of stored energy. Gram for gram, it contains more than twice as much energy as carbohydrates or proteins. When plants become scarce, the camel slowly breaks down the fat inside its hump to fuel its body. This isn't just theory. Scientists have observed that during long periods without enough food, a camel's hump actually shrinks. It can become smaller, lean to one side, and even droop over. Once food becomes plentiful again, the hump gradually fills back out again. In other words, the hump works like a rechargeable energy reserve. But here's the twist that surprises many biologists. Energy storage isn't the only reason the hump exists. In fact, where that fat is stored may be just as important as the fat itself. Think about wearing a thick winter jacket on a blazing summer day. The jacket traps heat close to your body, making it much harder to cool down. Body fat works in a similar way. It acts as insulation. If a camel spread thick layers of fat evenly beneath its skin like many other mammals do, that insulation would trap heat across its entire body. In the desert, that's exactly what the camel doesn't want. Instead, evolution concentrated most of that fat into one large hump, or two, depending on the species. By keeping much of the fat in one place, the rest of the body has far less insulation. Heat can escape more easily through the neck, legs, and sides, helping the camel avoid overheating. It's a remarkably elegant design. The hump itself isn't cooling the camel. Rather, it prevents the rest of the body from becoming wrapped in an insulating blanket of fat. Even so, the hump alone isn't enough to explain the camel's incredible endurance. In reality, it's only one part of an entire survival system that works almost like a perfectly engineered machine. Consider water. Despite the old myth, camels absolutely do need to drink. They can't survive forever without water. What makes them extraordinary is how efficiently they use every drop they have. Most mammals begin to fail after losing a relatively small percentage of their body water. Camels, however, can survive losing around 30% of their body water, a level that would be life-threatening for humans and many other animals. How? Their kidneys remove waste while wasting remarkably little water, producing highly concentrated urine. Their digestive system removes even more moisture before waste leaves the body, resulting in very dry feces. Even every breath is carefully managed. Inside the camel's long nasal passages, moisture from warm, humid air leaving the lungs is cooled before it escapes into the dry desert air. As the air cools, water condenses onto the surfaces inside the nose instead of disappearing into the dry desert air. The next breath reabsorbs much of that moisture. It's like breathing through a tiny natural recycling system. Then there's body temperature. Humans begin sweating as soon as body temperature rises slightly because our bodies work hard to stay at nearly the same temperature all day. Camels play by different rules. Their body temperature naturally rises during the hot daytime hours and falls again during cool desert nights. By allowing this wider temperature range, they reduce the need to sweat, conserving precious water that would otherwise evaporate away. It's a strategy that would make many other mammals dangerously overheated, but for camels, it's a normal part of daily life. Even their appearance reflects millions of years of adaptation. Their thick fur may seem strange for desert animals, but it shields the skin from intense sunlight while reducing the amount of heat reaching the body. Their broad, padded feet spread their weight on loose sand like natural snowshoes. Long eyelashes and closable nostrils help protect against blowing sand during fierce desert storms. Each feature solves a different problem. Together, they create one of the most successful desert survivors on Earth. Not all camels look exactly alike, though. The familiar dromedary camel, found across North Africa and the Middle East, has one hump. The Bactrian camel, native to the colder deserts and steppes of Central Asia, has two. Scientists know both humps serve the same basic purpose, storing fat. But one fascinating question remains unanswered. Why did one lineage evolve a single hump while the other kept two? Researchers suspect the answer lies in millions of years of separate evolution, shaped by different climates, landscapes, and metabolic demands. Genetic studies have revealed many specialized changes linked to fat metabolism and water conservation. But the complete evolutionary story behind one hump versus two is still being investigated. Nature rarely reveals all its secrets at once. The camel reminds us that evolution often solves problems in ways that seem completely backwards. A giant lump of fat sounds like the last thing an animal should carry through a blazing desert. Yet by storing energy in one place instead of everywhere, the camel not only prepares for famine, but also helps the rest of its body release heat more effectively. Add water-saving kidneys, moisture-recycling noses, flexible body temperatures, protective fur, and countless other adaptations, and the famous hump becomes just one piece of an extraordinary survival strategy. So the next time you see the silhouette of a camel crossing the sand, don't imagine a water tank swaying on its back. Imagine millions of years of evolution shaping an animal into a masterpiece of efficiency, where even the strangest-looking feature exists for a reason, and one simple hump tells a story far more remarkable than the myth that first made it famous.